Okay, here we go. Example 5. We need to use PEMDAS to simplify the expression. 12 plus 3 times 4 minus 2. So when we use PEMDAS, we read it from left to right, and we see parentheses occurs first. So we need to check to see if there are any parentheses, and there are, right here. So 4 minus 2 is 2. And then at this point, the parentheses are no longer necessary, so we can just get rid of those. Now we have 12 plus 3 times 2. Again, look at PEMDAS from left to right. Do we have any parentheses? No. Do we have any exponents? No. Do we have either multiplication or division? Yes, we do. We have 3 times 2. So PEMDAS tells us to do that next. We have 12 plus 6. 12 plus 6 is 18. So the solution is 18. Example 6. Once again, we want to use PEMDAS to simplify the expression. Read PEMDAS from left to right. Do we have any parentheses? No. Do we have any exponents? No. Do we have multiplication or division? Yes, we do. We have multiplication right here. 2 times 7 is 14. So now we have 4 minus 6 plus 14. Next up in PEMDAS, we have addition or subtraction, right? We have some subtraction happening here. So let's do that first. 4 minus 6 is negative 2. So now we have negative 2 plus 14, and that equals 12. So the solution is 12. Here we have 3 times 36 divided by 9 plus 6. Do we have anything in parentheses? Yes, we do. 36 divided by 9 right there. We know that that's 4. So the stuff in the parentheses simplifies to 4. Now we have 3 times 4 plus 6. And the parentheses aren't necessary anymore, so we can just get rid of those. And we have 3 times 4 plus 6. We need to take care of the multiplication before we do any addition. All right, so we have 3 times 4, which is 12. Now we have 12 plus 6, which is 18. The solution is 18. One more of these simplification problems. We have 6 divided by 2 minus 81 divided by 3 squared. So in parentheses, we have kind of a mess right now. We kind of have some junk, and we want to clean that junk up, right? We want to clean that up. So 81 divided by 3 squared. We need to take a look at operations. We take a look at order of operations inside the parentheses themselves. So this is a PEMDAS within a PEMDAS. We see that we have some division and we have some exponentiation. PEMDAS tells us that we need to take care of the exponent first. So we have 3 squared, which is 9. Now we have 6 divided by 2 minus 81 divided by 9. We still haven't cleaned up the stuff in parentheses, so we need to finish that right now. 81 divided by 9 is 9. So once again, the parentheses aren't going to be necessary at this step. So we have 6 divided by 2 minus 9. Look at PEMDAS one more time. Do we have parentheses? No. Do we have exponents? No. Do we have multiplication or division? Yes, we do. We have division right here. So 6 divided by 2 is 3. And we have 3 minus 9. And 3 minus 9 is negative 6. So the solution is negative 6. Here we want to solve an equation. It's been a long time since we've done this, so let's use the properties of the real numbers and PEMDAS to make sure we solve this equation correctly. We need to isolate x on the left-hand side of the equation. And one way we can do that is to get rid of the parentheses by using the distributive property. We saw this property last video. 8 times x plus 3 is the same thing as the product 8x plus the product 8 times 3. So on the left-hand side, we actually have 8x plus 24 equals 64. Let's move this to the top. And let's continue isolating x. I'd like to add something to both sides to isolate the x. And what I'm going to add is negative 24. All right, we're subtracting both sides by 24. That leaves us with 8x equals 40. Now I want to divide both sides by something, and that something is 8. On the left-hand side, the 8's cancel, and it leaves us with x equals 5. So we successfully isolated the x on the left-hand side of the equation by using the distributive property. And then the additive property of equality and the multiplicative property of equality. See the first video for the explanations of those. Our solution to this problem is x equals 5. Here we have 4 times 3 minus 1 times y equals 4. So I want to solve for y by isolating it on the left-hand side once again. So in parentheses, let's take care of that first. PEMDAS tells us to take care of that first. So we have 4 times 2 times y on the left-hand side, and that leaves us with 8y equals 4. When we divide both sides by 8, the 8's cancel on the left-hand side, and it leaves us with y equals 4/8. But that reduces down to y equals 1/2. So the solution is y equals 1/2. Here I want to solve for x again, and this looks similar to what we've seen already. We know we want to use the distributive property to isolate x, but this time it's a little bit different because the stuff in parentheses, we're actually used to seeing addition there, but here we have subtraction. So I'd like to change this subtraction into the following. I have 11x plus a negative number, right? Subtraction is just addition by a negative number. So now this looks like something that we've seen before when we use the distributive property. We have something plus something in the parentheses. So we distribute the 2 to the 11x and to the negative 4. That gives us 22x minus 8 on the left-hand side. Let's move this to the top. And we have 22x minus 8 equals 36. Let's add 8 to both sides. And that gives us 22x equals 44. Now let's divide both sides by 22. And the 22's will cancel on the left-hand side. And that leaves us with x equals 2. The solution to this problem is x equals 2. Last example. Here I want to solve for w. This business in the parentheses, this looks pretty messy, so we want to clean this up before we isolate the w. So in the parentheses, I have 7 minus 2, which is 5. Next, I have 5 being squared here, so I'm going to rewrite that as 25. I have 4 times w times 25 on the left. And the commutative property of multiplication tells us that it doesn't matter what order we multiply this in. We can switch it around like this if we want to. I haven't changed anything by doing this. So now we have 100w equals negative 200. Let's move this to the top. And we divide both sides by 100. The 100s cancel on the left-hand side, and we're left with w equals negative 2. So the solution to this problem is negative 2.